will hopefully get put up on Canvas. All right, so here we go. Also, and as an addition, I can't remember if it was yesterday or not because, of course, we had the snow day on Monday. But I think it was yesterday was National Cuddle Day. So if any of you have pets, make sure you go home and cuddle your pets or give your mom or dad a big hug. Okay, hugs are very important. All right, so day one, simplifying. We are multiplying here in this first problem, a monomial, one term times a binomial. What's that one property called that we use over and over? Distributive, yes. So we are distributing and multiplying this term 4x times each of the terms inside parentheses, okay? So we take 4x times x. Now some of you are probably past this point, but I'm going to write it down here anyway. And 4x times 3. Okay? So 4x times x. When you are multiplying two powers that have the same base, and these are powers because we can put a 1 on it, what do I do with the exponents? You add them, right? So this becomes 4x to the second minus, here I can multiply 4 times 3 is 12 and have 12x. So the final answer is 4x squared minus 12x. How many had that for an answer? Good. If you didn't, hopefully you can see now what it is you need to do. Any questions about this first problem? All right, the second problem adds an additional step, okay? This is a binomial times binomial, and there are two different methods we can use. We can use double distributive method, okay? Or we can use what's called the box method. How many like the box method better? How many like double distributive better? How many didn't vote? Several of you didn't vote. Of the ones that did, it looked like most people like the box method, okay? So I'm going to do the box method. If you want to see double distributive, I can do that in just a minute. So the box method starts out by looking like, we'll say a box. It's really a square that we divide into 4 sections, okay? The first binomial has 2 terms, and we put those terms above the box, okay? So 3x minus 1, those terms go over each of those columns. And then on the second side, we have the x plus 2, okay? And it's kind of distributing within the box. So I have here x times 3x, and I have x times a negative 1. If you put those together, the 3 comes out front. That's called the coefficient. X to the first times x to the first. You add those and get x to the second. A negative 1 times x is going to be negative 1x. And then we do the same thing for the second row. We take 2 times 3x, and we take 2 times negative 1. What's at the top? 2 times 3x, 2 times 3 is 6, and just 1x by itself. And 2 times negative 2 is negative 2. When you have the box method, the diagonals usually are going to be your like terms that you need to put together. So when I write these all down, I have 3x squared, that's in my upper left-hand box, negative 1x. I have a 6x, and I know I need to combine these because they are on that diagonal, and minus 2. So putting it all together, 3x squared, that's the only x squared term. Negative 1x plus 6x, you only combine the coefficients, the numbers in front. So negative 1 and 6 make 5x, And then minus 2, that's my only constant. So after putting and multiplying these binomials together, my final answer is this trinomial, 3x squared plus 5x minus 2. How many had that for an answer? Nice. If you did not, do you understand how to do it now? And I know you've seen this before, but maybe you didn't catch it the first time. Does anybody want to see the double distributive method? If you got the same answer, that means you got the right answer and you did it correctly. Okay? All right, so this should have been some review. Hopefully it was. Hopefully that gives you a little bit of confidence as we go into the next part. Any last questions about this? Okay, so next, we're going to end up having 3 different packets for this module. Okay, this is module 11B. It's all on factoring. So the next thing you are going to get is the notes packet. And it's important to keep all 3 of these. Okay. Now, if you were here yesterday, you heard me talk about what can I do to be successful? It is to take notes and really pay attention as the notes are being taken. Okay? Try to understand what's going on within the notes. Ask questions when you don't understand something within the notes. And finally, do the homework. Okay? All right. So the front page gives you the standards that the state says these are the standards you need to learn. So those are on the front page. I'm not going to read those over for you. Let's go into page 2. If we hadn't had the snow day, we would have done like 1 page of review. Hopefully we'll get to some of these. So this is just adding, subtracting, and multiplying polynomials, which is what you did right at the very end of your last semester. And finally, let's go over to page 3. So this is using the distributive property in reverse. So everybody got a packet? So this is page 3. Okay? All right, so you can use the distributive property to factor a polynomial. What the heck is a factor? Did she just say heck? Yes, she did. What is a factor? If I give factors of 6, is that like 6, 12, 18, 24? Or are factors of 6, 1 and 6, 2 and 3? Does anybody know? The second one, yes, factors. So factors, you might put up here somewhere. Factors are 2 or more terms which multiply to give you the answer. And that answer is often called the product. Okay? So factors are actually smaller than the number itself, except for, like in 6, you're talking about 1 and 6. 6 is a factor of 6. Okay? So distributive property. They give us 3y times quantity 2y plus 5, which is 3y times both of those. It gives you 6y squared plus 15y. You're like, very nice, very nice. Factoring is really just reverse distributive property, okay? It's where they give you the answer, 6y squared plus 15y, and say, hey, what is the largest number I can divide out of both of those two terms, okay? So here they factored out 3y and 3y, and said 3y times 2y gave me 6y squared. 3y times 5 gave me 15y. So then they factor out what is common to both, which is that 3y, and leave the rest of it in parentheses. Okay? So this process is known as looking for the greatest common factor. Oh, I spelled that wrong. Greatest common factor. When you are trying to see what numbers divide out of those terms evenly, the greatest common one. And it's also known as the GCF. And that is the first step of when you are trying to factor, is you always need to look for a greatest common factor. Okay? All right, so let's take a look at these. Find the greatest common factor of these following terms. There are two terms here. Okay? So I have 6 and 8. I want to write down all the factors of 6, and I'm going to do them in pairs. Okay? First of all, 1 is always a factor of every number. And 1 is always a factor in pairs with the number itself. So 1 and 6 are a pair of factors. What's another pair of factors for 6? 2 and 3. So there's a pair of factors. Are there any other factors of 6? You can just tear that up and put it in recycling. I am big on recycling. So tear it up, put it in recycling. 1 and 6, 2 and 3. So I often start with 1 and I come down this way. And then you've got 3. You've already known, well, 3 is a factor with 2. And there wasn't anything other than 1 and 6. So you know you've got all your factors. Now let's take a look at 8. 1 is always a factor of every number and 8. Next, go to 2. 2 and what is a factor? 2 and 4. How about 3? Is 3 a factor of 8? 3 times something give you 8 evenly? No. And then how about 4? Oh, we already have 4. So you know you've gotten all of your factors of 8. Okay? Then we have x to the third and x to the fifth. X to the third, if I write that out, is x times x times x. X to the fifth is 5 x's multiplied together. We are looking for the greatest common factor. Crystal, put that away. Let's be with me, okay? Thank you. So looking at the factors of my coefficients up here in the top, where is the greatest common factor for both of those coefficients? 2. Circle it. Make it obvious for yourself. Okay? And then looking at the x's below, how many x's can I take away or factor out that is common to both? 3. So putting that together, that means my greatest common factor is 2x times x times x, but we already know that is better known as 2x to the third. That is your greatest common factor. Questions on that? Let's see. Gavin, Mr. Hatch, can you tap him on the shoulder? Good morning, Sunshine. How are you? Do you have a notes page? Okay. I don't want you to miss out on this, okay? All right, so let's try and find the greatest common factor of these next two terms, okay? First of all, start with your coefficient 12. And then I want you to write them down for now. Write them in pairs. So we got 1 and 12. How about 2? Is 2 a factor that goes evenly into 12? Yes, 2 and 6. How about 3? 3, do I have, yep, 3 and 4. Hey, and 4, that's the next number, so you know you've got all your factors, okay? Do the same thing with 16. What are all the factors of 16? Stay with me. So we say 1 and 16. How about 2? 2 and 8. How about 3? No, 4? 4 and 4. Okay. So we've got all those factors. A squared means A times A, and 16A is just 1A. I need the greatest common factor. So looking above, up here for your coefficients, what is the greatest common factor? 4. Yes, it's here for the 12 and here for the 16. And how about my variables? How many can I take away? What's the greatest common factor of my variables? 1. So down here, my GCF, greatest common factor of these is 4 times A. And remember, these are factors, so you do multiply those together. Any questions about that so far? All right, let's move on. So now it says we're going to use this reverse distributive property to factor each of those polynomials, okay? And eventually you're going to get to a point where you don't have to write them down. All right, so you may or may not remember these two numbers, or this binomial is what we just had at the bottom of the last page. So 12 and 16, I want to find the greatest common factor. I'm going to see if I can do it in my head for a minute though, okay? Start with the smaller coefficient, okay? Start with the smaller coefficient. And ask yourself, does the largest factor of your smaller number divide into the other coefficient? So does 12 go into 16 evenly? No. So as you're thinking, and hopefully you're kind of doing this in your head, but you can still write these down, okay? 2 and 6. So then you're asking yourself, what about the second largest factor? Does 6 go into 16 evenly? Does 16 divided by 6 give a whole number? No. Okay, so then you go to the next one. 4. Does 4 divide into both of those evenly? Yes. So I know I'm dividing by 4 for both of them, because I know it goes into 12, and we just said it does go into 16. Now, so you start with the smallest coefficient, you look for the largest factor to divide into the largest coefficient. Now that's a lot of writing. But we just found the largest factor of the small coefficient that went into the larger coefficient, okay? And then finally, we look at and find the smallest exponent of your variable. The smallest exponent of your variable. So if I have a squared and a, which one of those am I going to divide by? Which the smaller of the two? Am I going to divide by a squared? Am I going to divide by a? A, yeah. You're going to divide by a because this only has one a. So the greatest common factor that you can take is 1 from each of them. So this is your GCF. but we don't have to find our GCF here. We're supposed to use this distributive property. So I'm going to factor that out and divide that out in front. So divide by 4a, and this is reverse distributive property. So then we actually divide. What is 12 divided by 4? 3. And what is a squared divided by a? If you have two a's and you divide by one of them, how many a's do you have left? If I have a times a and I divide it by an a, you only have one a left. Remember, you subtract when you are dividing. You subtract the exponents. So then here's my plus sign. And what's 16 divided by 4? 1. No, 4. Sorry. And a divided by a is 1. 4 times 1 is just 4. So that's your answer. So final answer is 4a times parentheses 3a plus 4. 4a is your actual greatest common factor. That's what we divide it by. All right? So let's do a few more of these. Everybody ready to move on to the check? Okay, so let's go down here. Letter A says 14g to the third plus 5g to the fifth. Look at your coefficients first, 14 and 5. Pick the smaller one, 5. Think of the largest factor of 5. What's the largest factor of 5? 5, right? Does 5 divide into 14 evenly? No. 5 is also a prime number, which means the only factors are 5 in itself. So the only thing that is going to divide by for both of them is 1. Okay? So that is your greatest common factor of 14 and 5. Now, let's look at the variables, g to the third and g to the fifth. How many g's, what's the most g's that I can take away from both of them? G to the third, right? So I write g to the third and g to the third. So what I am dividing by here, this is my greatest common factor. And so I bring that out in front. 1g to the third. And then I set up my parentheses. So then you actually look back at it and you divide. 14 divided by 1 is 14. G to the third divided by g to the third. Well, that just cancels out. So that's a 1. Plus, you bring down that same sign that's right there. 5 divided by 1 is 5. And g to the fifth divided by g to the third. How many g's do you have left? Not 3, 2. Because remember, you subtract when you divide powers with the same base. So that is g to the second. Oh, I always get all these little things. So final answer, 1g to the third times 14 plus 5g to the second. You have just factored this binomial, okay? Questions on that? Let's jump to letter D. Letter D. I want you to try this one on your own, okay? I'm going to talk through a little bit of it, but I want you to try it on your own. First of all, look at your coefficients, 12 and 8. Pick the smaller one of the two. What's the largest factor of 8? 8. Does 8 divide into 12 evenly? No. What's your next largest factor of 8? 4. Does 4 divide into 12 evenly? Yes. So that's going to be your greatest common factor. Okay? Oh, Miss Thede, there's two variables. We haven't done an example with two variables. You're right. Follow the process, though. You've got an x to the first and x to the fourth. How many x's, ask yourself, can I take away or factor out of both of them? Okay? Ask yourself that. So, how many x's can I take out? This has 1. This has 4. You can only take away the same amount from both. How much can you take out? And then do the same thing for the y's. You have y to the third and y to the first. How many y's can you divide out of both? Okay. All right. So, after a little bit of talking there, no, that's not what I wanted. How many x's can I divide out from both of them evenly? 1. Yeah, there is only 1 here. You could only take away 1 if you only have 1. And what about my y's? How many y's can I take away from both? 1. So guess what? This and this is your GCF, which gets factored out in front. So 4xy, come on, is what I have factored out in front. This is reverse distributive property. So now let's divide. What's 12 divided by 4? 3. What is x to the first divided by x to the first? No, it's 1, because it's the same thing, right? Crystal's like, it's 1, yeah. And y to the third divided by y, how many y's do you have left? Think about it. You have 3 y's. You're dividing by 1. How many do you have left? 2. Plus sign in between. 8 divided by 4 is 2. X to the fourth divided by x. You have 4 x's on top. Divided by 1, how many do you have left? 3. 4 minus 1 is 3. And y divided by y, you don't have anything left, times 1. Put in your end parentheses, so your final answer, 4xy times 3y squared plus 2x to the third. Well, that's not so bad, right? This is only step 1, but you really need to understand this before we go on. All right, let's go to letter B. 2x to the third plus 6x squared plus 8x. Ms. Thede, this has 3 terms. We haven't done 3 terms. I know. Isn't that fantastic? So looking at your coefficients, I want the greatest common factor, but you look at the smallest coefficient first. What's my smallest coefficient here? 2. Does 2 divide evenly into 6 and 8? Ding, 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 ding. We have our greatest common factor for the numbers already then. So always look at your smallest coefficient first. All right, then we have x to the third, x squared, and x. What is the greatest number of x's that I can divide from each term? 2, 1. 1, 2. Do you feel like you're at the eye doctor? Which is better? 2, 1. 1, 2. 1, right? This only has 1x, so we can only divide by 1x. And guess what? This is your greatest common factor that is divided out front. So 2x is your greatest common factor. And when you divide, 2 divided by 2 simplifies to 1. So there's nothing there. X to the third divided by X. So you have 3 X's, and you divide by one of those X's. How many X's do you have left? 2. Plus 6 divided by 2 is 3. X squared divided by X is how many X's? X squared divided by X. X, yes, because there were 2. You divided by 1, which knocked them out, and you had 1 left. And 8 divided by 2? It's okay, you can say 4. And x to the first divided by x to the first, that cancels out. You are left with this right here. Notice, and this is what usually should happen, each of these x values go down by 1. This is x squared, this is x to the first. X to the 0 would be 1. So final answer is 2x times x squared plus 3x plus 4. Okay? Questions on that? All right, I want you to do C. Try C on your own. Look at your coefficients. While you're doing that, I will pass out your first homework. I know you're so excited. Homework the first week. Try C on your own, please. Hey guys, try C on your own, please. 1, 2, 3. All right, you might not be totally done with C, but let's take a look. So let's look at our coefficients. We have a 6, or do we? We have a 6, come on, 6, we have a negative 18, and we have a 21. The smallest coefficient here is 6. Now, does 6 divide into all 3 of those evenly? No, it does not go into 21. What is the next largest factor of 6? 3. Does 3 divide into all of those? Yes. So we're going to divide by 3. Now let's check our variable. I have an x squared, an x, and no x. So how many x's can I divide out of all of those? None, because this last one doesn't have an x. So my greatest common factor here is just 3. This is your GCF. Now let's divide. So 6 divided by 3 is 2, and you have an x squared left, minus 18 divided by 3 is 6, with an x left. And plus 21 divided by 3 is 7. Okay? So final answer, 3 times parentheses, 2x squared minus 6x plus 7. How could I check any of these problems? How could I do a quick check if I wanted to? Couldn't you just multiply it back and use the distributive property? Yeah, 3 times 2 is 6, x squared, minus 3 times 6x, 18x, plus 7 times 3 is 21. Okay? All right, take a look at the homework packet I just passed out. Don't worry, you don't have to do all of these. This first page, which says homework 1, 11.5, using the distributive property, this is due on Friday. This is front and back. You should be able to do all of the front page today using the same kind of stuff that we did today. Okay, look for the greatest common factor. You will not be able to do this on the back side yet until after tomorrow. Okay? But write it up here at the top, due Friday. Yes. Okay? So, everybody, it's a new year, a new semester. Let's everyone start on the right foot. Get it? Right foot. Haha, right foot. Let's work on this homework and let's try to have that done by Friday. Yes, ma'am. Try what? Band-Aid, yes I do. So, greatest common factor, that again is the first step of any factoring that we do. And there's like 4 other types of factoring. So this is the first step. All right, have a great rest of your day. Be kind to someone. Push your chairs in as you leave, please. Yeah.
Would you mind if I come 5th period?
5th period?
Yeah, like I'm saying, because since they didn't put me in a recess this semester, I
Uh-huh.
don't really have like a place to finish. Like I still got like, they still have my IEP, but I don't have recess.
Okay.
So I was saying like when we do tests,
Uh-huh.
would you mind? Because I know my biology teacher wouldn't mind because I finished my work in there, but
Okay. Yeah. I think
that.
that would be fine. Yeah.
Or stress coming up to school. Because I don't know why they did that. Like they know I don't know.
Why don't you, have you tried to connect with your counselor?
I emailed her 5 times.
Who is
Kendrick?
Kendrick? Okay.
I emailed her before we even started school.
Because you had seen your schedule maybe? Or not?
No?
Because you had already seen your schedule?
Yeah, that's why I emailed her before we started because I knew she wanted to answer if I just emailed her.
Right.
But like she had not answered at all.
Huh. Well, I'm sure she's got a lot going on, but yeah, that is a little frustrating.
I'm just trying to tell her before, like, you know, like, it's too late and she's like, oh, you can't switch your classes.
Yeah.
So, alright, I'll see you later.
Okay. Hey, you can grab a book.
I was able to get my study hall changed to credit retrieval.
Oh,
Got out
good.
at APC.
Great.
Yeah, so I'm happy.
Looking good then.
Oh yeah.
Nice. Success.